Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about the arc lengths and the area of a sector. So let's say we're given a circle with a radius r. So if you would subtend an arc with the length exactly equal to this radius of a circle, then the central angle would be measured in as 1 radian. So this is basically the definition of the radian. So this is the measurement of an angle where the arc length is subtended with the length of equal to the 1 radiuses. And essentially the 2 radians is going to be equivalent to the arc length which is subtended by the 2 times to the radius of the circle. So this is going to be 2 times to the radius. And if you would like to just walk subtended arc with the half a circle, then this measurement is going to be equal to the pi radians. And this is essentially means that in order to just the distance which you can walk on the circle until the half of the circle is going to be equal to the pi times to the radius. So now let's say I would like to understand what is going to be the arc length of a circle subtended by some angle, let's say theta. So let's say, so the arc length subtended by this angle theta is going to be equal to the s. And at the same time, let's say the arc length which is subtended by the angle theta 1 is going to be equal to the s1. So what is true about this length and this length S1 is that the ratio of the arc lengths S divided to the S1 should be equivalent to the ratio of the angles theta divided to the theta 1. So let's say from here I can find the S, so the arc length which is subtended by the angle theta is going to be equal to theta divided to the theta 1 times to the S1. So at the same time, by the definition, if the theta 1 is equal to the 1 radians, or 1 radian, then S1, the arc length which is subtended by 1 radian, is equal to simply to the radius of a circle. So this is essentially the definition of the radian, right? So I'm going to just substitute theta 1 to be equal to the 1 and S1 to be equal to the r in order to get the formula for the arc length, which is going to be equal to the s is equal to the theta times to the radius. Okay, so this is going to be the length of the arc subtended by the central angle theta. So at the same time, please note that if the theta is equal to the 2 pi, which is essentially 1 time rotation around the circle, right? 2 pi, then the arc length, which corresponds to this, which is essentially the circumference of the circle, right? So is going to be equal to the 2 pi r. So this is called the formula of the circumference. So this formula is going to give us the length of the arc subtended by this angle theta. And this is going to give us the circumference of the whole circle, which is essentially the arc, which is subtended by the angle 2 pi. So at the same time, I would be interested to figure out the area of a sector subtended by some angle theta. So and again, so I'm going to try to do the proportion. So let's say I've got this area, which is subtended by some angle theta 1. So this area is going to be, let's say, equal to the A1. At the same time, the area which is subtended by another angle theta 2 is going to be equal to the A2. And again, the ratios of the areas should be equal or equivalent to the ratios of the angles. So essentially A1 divided to the A2 is equal to the theta 1 divided to the theta 2. So from here, for example, I can find A1, which is going to be equal to the theta 1 divided to the theta 2 times to the A2. So at the same time, I need to mention that whenever the theta 2 is equal to the 2 pi, so essentially, what is the whole area of a circle, right? So the theta is 2 pi means the sector is going to be the whole circle. The area of the whole circle is equal to the pi r in the square. So I'm essentially going to just substitute these two formulas to here in order to find the area of a sector, which is going to be equal to the theta, so the area which is subtended by some angle, right, times 2z, so the pi r in the square divided to the 2 pi. So I can just cancel out those pi and pi here. So this is what we get as essentially 1 over 2 theta r in the square. So again, so the area of a sector which is subtended by some angle theta, by the central angle theta, is going to be equal to the theta times the radius in the square divided by 2. So let's do a couple of exercises. So a central angle x is subtended by an arc 10 centimeters long on a circle of a radius 4 centimeters. So we first of all need to approximate this x in terms of the degrees, minutes, and seconds. Then we need to find the area of a circular section determined by the x. So and again, so what we are given is essentially we're given a circle, right? Was the radius, so let me draw the radius. So the radius of the circle is equal to the 4 centimeters. So at the same time, we are given that the arc length, which is subtended by, okay, so the central angle x is subtended by an arc 10 centimeters along with the circle. Okay, so if I would just draw the arc with exactly 20 centimeters or 10 centimeters, sorry, 10 centimeters, then this angle would be equal to the x. Okay, so I need to figure out this x first of all. So I'm going to use the formula of an arc length. If you remember, the formula of the arc length, which is subtended by some angle theta, is equal to the s is equal to the theta times the r, right? So essentially, the x times the radius should be equal to the arc length. So from here, we can easily find the x. X is going to be equal to the s divided to the r. So which is like essentially 10 centimeters divided to the 4 centimeters. So if you just like divide everything out, what you get is 2.5 radians. So please note that this formula is always going to give us the measure of an angle in terms of the radians. So now what we need to do is we need to convert this into the angles, into the degrees. So in order to do this, we need to use the proportions. So essentially, if you remember the definition of the radian, so it was like, hey, so if you would just like walk a half a circle, which is equivalent to the 180 degrees, it is going to be equivalent to the pi radians. Right, so this was the definition of it. So this is the equation which helps us to transform the degrees into the radians and also the radians into the degrees. So I'm going to use this formula. So let's say we are given the angle which is equivalent to the 2.5 radians. I would like to figure out this in terms of the degrees, right? So in order to do this, I'm going to use an equation. So the 180 degrees is equal to, or is equivalent to the pi radians. So what is going to be the degree which equivalent to the 2.5 radians? Then I'm going to use the proportion. So x times to the pi should be equal to the 180 times to the 2.5. So again, so the x times to the pi should be equal to the 180 degrees times to the 2.5 radians. So here the pi is also in terms of the radians. Okay, so we can just neglect them because we've got the radians in both of the parts. So from here we can find the x. It is going to be equal to the 180 degrees times to the 2.5 divided to the pi. So this is equal to 450 degrees divided to the pi, which is roughly equivalent to the 143.24 degrees. So essentially, this x is going to be equivalent to the 2.5 radians or 143.24 degrees. So at the same time, it would be super interesting for me to figure out the degrees, so this angle, the measure of this angle, in terms of the degrees, minutes, and the seconds. So please note that, so 1 degree is equivalent to the 60 minutes. So we call this as a minutes. At the same time, 1 minute is equivalent to the 60 seconds. So we call this as a second. So this all are the measurements of an angle, not the time. So what we need to do is we need to just write down 0.24 degrees in terms of the minutes. And again, so I need to figure out its representation in terms of the minute by noting that 1 degree is equal to the 60 minutes. I can figure out the x from here. So essentially, if you just solve this by the proportions, you will get that the x is going to be equal to the 0.24 times to the 60 minutes. So if you just make the multiplication, what you get is 0.24 times to the 60 is equivalent to the 14.4 minutes. So at the same time, this 0.4 can be written as 1 in terms of the seconds. And again, so I would like to understand what is the representation of the 0.4 minutes in terms of the seconds by noting that 1 minute is 60 seconds. And again, I can find the x by proportions. From here, the x is going to be equal to the multiplication of the 0.4 to the 60 seconds, which is going to be equal to the 24 seconds. Okay, so essentially 143.24 degrees can be written as a 143 degrees, 14 minutes, right? So here I've got a 14 minutes and 24 seconds. So this is how we need to transform the radians into the degrees, and then the degrees into the minutes, and then the minutes into the seconds. So there's still some part of the problem which we didn't cover, which we didn't solve. So let's say this is going to be the point number 4. So we need to find the area of a circular section determined by this angle x. So essentially we need to find this area. And again, you can try to solve this using the proportions if you don't remember the formula of an area of a sector. So you just need to remember that the area of a circle, which corresponds to the 2 pi, is equal to the pi r in the square. Okay, so this is the only thing which you need to remember. So at the same time, we are given the radians, which is 2.5 radians, and what is going to be the angle, or what is going to be the area which corresponds to this 2.5 radians. And again, I'm going to do the proportions. So the x times to the 2 pi is equal to the 2.5 times to the pi r in the square. So I can just cancel the pi's from both of the parts, and I can find the x, which is going to be equal to the 2.5 radius in the square divided to the 2. So now we need to use the radius. The radius was given as a 4 centimeters. I'm going to just I'm just going to substitute this there. So this is going to be 1 over 2 times to the 2.5 times to the 4 centimeters in the square. So if you just calculate all of these terms, you are going to get the answer, which is equivalent to the 20 centimeters in the square. So this is how we are going to find the arc length, which is subtended by some angle, the area of a sector, which is subtended by this angle. We know now how to transform the radians into the degrees and the degrees into the minutes and the seconds. So thank you very much for your attention. I hope that this video was